So this is a short video lesson on factoring by grouping. This will be very helpful as we move into the next day or the next video when we talk about grouping trinomials. But what we're going to do is go through just a few steps to help you kind of formalize this process, and then you can then try it on your own with your own example problems. So what we're going to do first is called grouping the terms. But to understand that, or to figure out what is the term that I'm factoring out, we have to first find where the GCF can be. Now, we've talked already about finding a GCF between two factors. So a factor times a factor is equal to a multiple. However, there was nowhere in my definition of a factor that stated that it had to be a monomial or a single term type of factor. Factors can also be binomials or trinomials, or any number of terms really. So here, I'm going to show you an example of where my first factor is a monomial, and my second term is multiplied to a binomial. So here, in our first example, I have 2x, which is a monomial, multiplied with, in parentheses, x plus 3. These two terms are being multiplied together. They are both factors of the same expression. The plus is what divides us into two different terms. Plus my next term, which is 5, a factor, times something that looks very familiar, the quantity x plus 3 of this term. Now, what factor do they have in common? The factor that they have in common is x plus 3. Now, remember, when we factored out a GCF, we then went back and we looked at what was left over. When I factor out an x plus 3, it's gone from my list. It's gone from my factor list. So what factors remain, and what remains is the 2x plus 5. So let's go through a couple more examples just to make sure we understand it. The plus divides my two terms, right? So that's my dividing line, if you want to visualize it that way. If I look at the front and I look at the back, what do they have in common? This x minus 4. So the x minus 4 is what I'm going to factor out in front. What's left over after I take out the x minus 4 and the x minus 4 is this x and this plus 3. So that's going to be my second term, x plus 3, as my remaining factors being added together. So if you get the gist of what we're trying to do, go ahead and try 3 and 4. Pause the video, try them, and then I'll follow up with giving you the correct answers for these. Be very careful here. X plus 4 is what I share. So that's what's going to be factored out in parentheses. However, what's left over is a 3x minus what? What is out in front of that? Now remember, with two factors, a factor times 1, is always itself. Okay? So therefore, that same factor. So here, since nothing's really being multiplied to 4x plus 5, technically there's a placeholder of a 1 in that space. In number 4 here, what do they have in common? 2x minus 1, 2x minus 1. And then what's left over is an x minus 1. After these are removed, what's left? X and a negative 1, which is invisible right now for us, but we can always know that factor times 1 is itself. So now we're going to go ahead and we're going to go through all of our steps of factoring. And we've already done the first few, but now we're going to look at that first one, which is grouping. So let's look at our first example here. Now we're going to factor a polynomial. Let's say a four-term expression. Obviously 12x and 4x are like terms, but right now we've broken them into two parts so that we can kind of split our function into two smaller binomials. So I'm going to draw a line here after the x and before the negative sign, and that vertical line splits my four-term polynomial into two terms. Now I'm looking at x squared and plus 12x, and I look at those two terms and I say, what is my greatest common factor that I can take out of those two terms? So when I look at x squared, I see an x and an x. When I see 12x, I see a 12 and an x. So since there's no common factor in terms of numbers, but there is a common factor of x, I'm going to take him out first. What's left over is when I take away an x from x squared, I'm left with an x, plus when I take an x away from x, they're gone, I'm left with just a 12. Now we're going to look at the second part of this expression, which is negative 4x minus 48. And I'm going to factor something that they both have in common out. Both are negative, so I'm actually going to factor out a negative 1 to start, which makes both 4 and 48 positive. Then I'm going to think about the numbers here. What two numbers do 4 and 48 both go into when I'm thinking about greatest common factors? 4 breaks down to 2 and 2. It also breaks down to 4 and 1. 48, if you're careful here, 48 is also divisible by 4. So when I do 48 divided by 4, I get positive 12. So really, I can take that entire 4 out, and what I'm left with is an x plus, be careful with the negative, I took the negative out, plus 12. X plus 12. Now, I'm just going to rewrite this, just to make sure we understand it and see it. This is, and then minus, not equal to, but minus 4. Now hopefully the colors help you visualize this, but now we're doing exactly what we did in examples 1 through 4. Now I'm going to look for a common factor out of the common group. So here I've taken my two terms and I've turned them into two factors. Here I've taken two terms and I've turned them into two factors. And now I'm looking for a common factor that these two groups share. So here I have an x plus 12. That is in both, so they're gone. And what I'm left with is this x minus 4. And now I've factored by grouping. Okay? So when you're going through these steps, just make sure you're really careful and you follow them to a T at the beginning, and it will get easier as we go. I'm going to draw my line down the middle. I'm going to look for a common factor here, like x. I'm going to write down what remains. And then here, I have to be really careful. I have a minus 2x and a positive 14. I like to be my lead term positive, so I'm going to take out a negative 2. And what that leaves me with is a positive x minus, be careful, because a negative 2 times a negative number is going to give me a positive 14. So negative 2 times a negative 7 gives me a positive 14. What do they have in common? They have the x minus 7 in common. So that's what's going to be pulled out. And after I pull out x minus 7, what's left over? An x minus 2. X minus 2. We got two more examples here. At any time, go ahead and feel free to pause, try them on your own, and then follow me after you do that. But these problems are pretty self-explanatory. I'm going to go ahead and draw my line. I'm going to take out my common factor, making sure that I always reduce. I take away the factor from, I write the remaining factors down from the multiples. Here I'm going to take out a negative 1, which doesn't seem like a big deal, but it actually makes the middle parentheses the same. And if you're going through this process and this is not equal to that, you probably took out the wrong factor. So then I have a c minus 3, and I also have the remaining outside factor, which is a 2c minus 1. Here, when I draw my line, I end up with a 2n that I can take out, and that gives me a 2n plus 5. Here I have a 6 and 15, so I'm going to take out a positive 3. That gives me a 2n plus 5 as well. That's a good sign, because parentheses are the same. This guy's this guy, so they're going to come out as my common factor of the two common groups. And what's left over is my 2n plus 3. So I'm going to have a 2n plus 3 here. So that was a quick review. Make sure you go back and watch the example problems to have a better understanding, and then try the examples below here as practice before you move into the homework practice.